Let's have like this. So first it's talking about the equilibrium. Let's proceed here. What about the mass of this mg? The tension, let it be at T. Since the same string, no, so the tension will be same. So this is T, this is T. Find the maximum value of M so that system does not move. How to manage this particular thing? So definitely the friction here should be maximum F2L. Mu1, mu2 is given F2L. So why the friction I should take here? Because you look at the tension here. Will be acting, so it will, this tension the rope will try to pull the block 3 kg towards right, and because of that the limiting friction should act here. What about the friction here for the equilibrium? We'll do one thing, we'll write first F1 F2 like this. No. Is it okay getting the direction of frictions? So treat this 2 kg as one block. So what is the role of this friction? Will become like internal, no? So therefore, when for maximum value of M for equilibrium, what happen here? The limiting friction will come. When M becomes maximum, this will become F2. So let's write the equation first. This will be two T should be equal to F2. Oh, combined block. So that F1 will become internal, will get eliminated. And this 2T further should be equal to mg. So therefore, mg should be equal to F2. So when M becomes maximum, this F2 will become limiting. So the maximum value of this will be F2L by G. This should be equal to mu2, 2 plus 3, 5 mu2. Okay, there's a maximum permitted value. Okay, after getting this one, mu2 value how much given? 0.5, 2.5 kg. Now he's asking what will be that F1 when it is this much here. I think definitely we can calculate 2T equal to mg. Then we'll calculate the F1 equal to T. So I'll proceed after this. F1 25. So T equal to 12.5 Newton. Then F1 equal to T. Okay, what is a T? 12.5. But what is the maximum permitted value of F1L? I think we need first. F1L will be anybody value 15 Newton. F2L 2, 3, 5, 25. Okay, you see this one. What is the nature of friction that is acting? Still, it is less than F1L. Will be static. Okay, there's the initial first part of the problem. Okay, now come forward. If M equal to 4 kg, so how much it is the maximum permitted value for equilibrium for no slipping? Find maximum value of M so that the system does not move. There'll be a test. That's what we discussed here. Now instead of 2.5 kg, I'll make it 4 kg. Find the tension the string attached to 2 kg block. Is asking what will be the tension, or is asking tension the string. Okay, second part of the problem. What is the situation? So will they will move together, or still it will be at rest? I think any of the cases can happen. Okay, I'll go for second part of the problem. Second part of the problem, it will be definitely the block will accelerate. So mg minus 2t should be equal to m. M is given how much? 4 kg. Yeah? So this will be 40 minus 2t is equal to 4a. Keep this equation in the hand. Then together, I'll assume that I'll show a small diagram so that it'll be easy for you. Here tension T and T. I'll assume that here limiting friction will act F2L and here a static friction and will act here, and let there have a common exertion E. So then the solving this one will be 2T minus F2L is equal to 2 plus 3 into E. Let me solve this. I'll calculate the tension. Anybody value T and E? First, let me add up this. Anybody value A? 2T, 4G minus 2T, no? So this will be 40 minus 25, 15, 15. Okay, 3 Newton. Oh, 4 A, no? 5A, 9A. 9A will be 40 by 9A. 40 by 9. 40 minus 15, 15 by 9. 15 by 9A or 15 by 9. Okay, 5 by 3. Yeah. Anybody value T? How much tension? Twenty-five by 3, 25 by 3, 25. 50 by 3. Okay, let's check now. I'll write equations of motion on the block 1. So T minus F1 equal to 2A. T value I know, 50 by 3. F1, this will be 2 into 5 by 3. 50 minus 10 by 3, 40 by 3. 40 by 3 will be 13.33 Newton. I think still less than F1L. No? So what will happen? What I assumed is right or wrong? No slipping occurs is what I assumed. In fact, correct, no? Condition assumed, no slipping. I got the F1 less than FL. In fact, what I assumed is wrong. Find the tension attached to the block. So what all I solved it, it's correct. So this is very important. A friction, this what actually students see. Don't assume that no slipping and do the problem and you get answer. Okay, sir, this is what happens. So first, no slipping occurs. Check it, no slipping occurs or not. So how to check it? Calculate the static friction, calculate the friction acting between 2 kg and 3 kg block. If it is less than F1L, then what we assumed is correct. Assumed condition is correct. Condition assumed is let me write clearly. Condition assumed is no slipping occurs between blocks. Fine. Put it like this. Okay, then you do it. So some students, I don't know what will happen to you in exam. They'll assume that slipping occurs and they do it. They'll get one value of tension and there'll be one option related to that value also, and you'll pick up, it'll come out. But always first go for no slipping, check it. Friction acting between block less than limiting, then what you assumed is right. F1 is greater than F1L, then slipping occurs, then you carry on problem. Just you wanted to test students that will they think like this. think there's a one where whenever friction comes between the blocks, no, I think there's a one natural way of analyzing here. Okay, similarly, can you work out other options, third and fourth, you try to solve, or leave it. There's a thing.